You know how you pick up your phone, open an app, and see all those visuals? Buttons, charts, images?
Yeah.
Or wonder, like, how they actually appear on the screen.
Right. It often seems like magic.
Exactly. Yeah. Well, you're in the right place. Welcome to the Deep Dive. We try to unpack complex stuff and make it understandable, fast.
And today, we're tackling the fundamentals of 2D graphics on Android.
Yeah, we've got some lecture notes here on Android Multimedia, and the mission really is to break down the core ideas. How do these apps draw things?
It's foundational knowledge, really. Even if you're not an Android dev, it's interesting to get a peek behind the curtain, see how those visuals come to life.
Okay, so digging into the notes, it seems like at a basic level, it's about two main things, either drawing shapes directly or just showing images the app already has.
That's pretty much the gist of it, yeah. Direct drawing, think lines, circles, text, or displaying existing image resources.
Like photos or icons.
Exactly. And for just showing those pre-made images, the notes point to something called image view.
Image view.
Think of it like a dedicated picture frame in your app's layout. You just tell it which image resource to display. Pretty straightforward for static images.
Gotcha. So image view, easy way to show a picture.
Right.
But what if the app needs to create visuals on the fly? Maybe like a custom graph or some animation?
Right, that's where direct drawing comes in. And the absolute cornerstone for that, according to these notes, is the bitmap class.
Bitmap. Sounds important. What is it exactly?
It's essentially an object that holds the actual pixel data for an image in the phone's memory. It's your digital canvas data.
Ah, okay. So not the drawing surface, but the image itself held in memory.
Precisely. The notes mention methods like create bitmap source that lets you create a bitmap object, maybe from another image or some other defined source.
Okay.
And there's another version, create bitmap source, XY, with height. This one's pretty neat and lets you grab just a specific rectangular part of an existing source image.
Oh, like cropping. So if I had a big picture, I could use that to make a little thumbnail bitmap.
Exactly that. Gives you a lot of flexibility. And then there's the bitmap factory. This class is all about creating bitmap objects from different kinds of sources.
Okay, so create bitmap makes them from existing image data. Bitmap factory makes them from other things.
Yeah, like from raw image data stored in a byte array that's decode byte array. Or from an input stream, maybe data coming over the network decode stream. Or just from a file stored on the device, using its path that's decode file. So different ways to get image data into a bitmap object in memory.
Okay, that makes sense. So we've got our image data loaded into a bitmap. Now, how do we actually draw something? The notes mention, like, 4 essential components needed.
Right, think of it like setting up an artist station. You need 4 key things.
Okay, lay 'em on me.
First, you need a bitmap. That's where the pixels you draw will actually be stored, your digital paper, in memory.
Got it. The bitmap, number 1.
Second, a canvas. This is the object that actually receives the drawing commands, like draw a line or draw a circle. It knows how to draw onto the bitmap. It's like your drawing surface or easel.
Canvas. Okay, bitmap to hold pixels. Canvas to draw on. What's third?
Third, you need something to draw. This could be a geometric shape, like a rectangle, or a path, a custom shape, or it could be text, or even another bitmap you want to draw onto your canvas.
Your subject matter. Makes sense.
And fourth, you need a paint object. This is crucial. The paint object holds all the style information, like color, line thickness, text size, whether to fill a shape or just draw its outline. It's your brush and paint set.
Ah, okay. So bitmap, pixels, canvas, drawing surface, an object, what to draw, and paint, how to draw it.
Exactly. Those 4 are the fundamental building blocks.
Let's talk about paint a bit more then, specifically color. How do you define colors?
Well, the color class is your friend here. The notes mention the easy way, using predefined constants like color.orred, color.bluey, color.green, etc. Simple enough.
Yeah, standard colors.
But for more control, there are static methods like color.rgba. Here you specify the alpha, transparency, red, green, and blue components individually, usually values from 0 to 255.
Right, RGB gives you total control over the mix, like millions of colors.
Pretty much. And there's also color.parseColor string. This is handy because you can use those web-style hex strings, like hashtag FF000 for red, or hashtag 80FS000 for semi-transparent red, or even color names like red or blue.
Oh, I've seen those hex codes everywhere. That's useful.
Very. The notes also briefly touch on getting colors defined in your app's resources, like in reesvaluescolors.xml. That helps keep your app's theme consistent.
Good practice. Okay, so solid colors are covered. But what about fancier stuff? Like gradients, fading from blue to green, or patterns.
Ah, now you're getting into shader objects. The paint object doesn't just have to use a solid color. You can give it a shader instead.
Shader. Okay, what kind of shaders are there?
The notes list a few. There's bitmap shader. This one's cool. It uses a bitmap image as a texture or pattern to fill shapes.
So you could fill a circle with like a wood grain texture if you had a wood grain bitmap.
Exactly. Then you have linear gradient. That's your classic smooth transition between colors along a line. You specify the start and end points and the colors.
Blue fading to green. Got it.
Radial gradient does the same, but radiating out from a center point. Think a circular burst of color.
Okay.
Sweep gradient is an angular gradient, like colors swirling around a central point. Think radar sweep.
Interesting.
And compose shader lets you combine two other shaders in various ways for even more complex effects.
Wow. Okay, so shaders give you a lot more visual richness than just plain colors.
Definitely. And one more thing about shaders. Tiling modes.
Tiling, like bathroom tiles.
Sort of. If your shader's pattern, like the bitmap shader's image or a gradient, is smaller than the area you're filling, the tiling mode tells Android what to do. Shader.tilemode.repeat just repeats the pattern.
Okay, it makes sense.
Mirror repeats it, but flips it each time, creating a mirrored pattern.
Ah.
And ClaimMP just stretches the color from the edge of the shader pattern to fill the rest of the area. No repeating.
Got it. Repeat, mirror, clamp. Controls how the pattern fills space.
Exactly.
All right, let's circle back to the paint object or brush.
Oh.
We know it handles color and shaders. What other key settings does it control?
It's really the main tool for styling. The notes highlight the most common methods. Set color sets that solid color we talked about.
Right.
Set text size float controls, well, the text size. Set stroke with float sets the thickness for lines or shape outlines.
Okay, thickness, important.
Very. Then there's set style. Paint style, this is key. You can set it to paint style stroke to only draw the outline.
Like a wireframe circle.
Exactly. Or paint style fill to fill the shape completely with the color or shader.
A solid circle.
Right. Or paint style fill and stroke to do both fill it and draw the outline.
Okay, stroke, fill, or both. Makes sense.
There's also set text align, paint align for positioning text left, right, or center relative to the coordinates you provide.
Useful for labels.
And crucially, set shader. Shader is how you attach one of those gradient or bitmap shaders we just discussed to your paint object.
So you create the shader, then tell the paint to use it with set shader.
You got it.
Okay, we have the bitmap, pixels,
Yeah.
the object to draw, the paint style. Now the canvas, that's where the actual drawing commands happen, right?
Absolutely. The canvas object is what you actually talk to when you want to draw something. All the draw something methods belong to the canvas.
How do you get hold of a canvas object, typically?
The most common way, as the notes explain, is inside a custom view. You create your own component that extends view, and you override its onDraw method.
Draw.
When Android needs to display your view, it calls onDraw and passes you a canvas object that's ready to draw on for that specific view.
So the system gives you the canvas when it's time to draw that part of the screen.
Exactly. It's the standard way to do custom drawing within your UI layout.
And the notes also mention creating a canvas from a bitmap directly.
Yes, that's the other main way. You can say, new canvas, my bitmap. This creates a canvas that will draw directly onto the bitmap object you provided.
Why would you do that?
Maybe you want to create an image dynamically in the background, off screen, like pre-rendering a complex graphic or generating an image file to save.
Ah, okay. Drawing without immediately showing it on screen.
Precisely. And when you do want the screen to update because your view's content has changed, you need to tell the system to redraw it.
Right, how?
You call invalidate on your view that signals, this view is dirty, please call onDraw again soon. But you have to call invalidate from the main UI thread of your app.
Only the main thread. What if something changes in a background thread?
Good point. For that, there's post invalidate. It does the same thing, requests a redraw, but it's safe to call from any thread. It just posts the request to the main thread's queue.
Invalidate from main thread, post invalidate from others.
Got it. And once you're inside onDraw with your canvas, you have this whole toolbox of drawing methods.
Yes, the notes list a bunch. Draw point, draw line, draw text. Basic stuff.
Right. Draw rect for rectangles, draw circle for circles, draw arc for parts of a circle or oval.
Draw arc seems useful for pie charts and things.
Definitely. And draw bitmap lets you draw one bitmap onto the canvas, which might be drawing onto another bitmap, remember?
Right, drawing images onto your surface.
The canvas also has methods to set the background for the entire drawing area, like draw color or draw RGB or draw RGB, like painting the whole canvas one color before you start.
Or draw paint, which sounds like it could apply a gradient background using a paint object with a shader.
Exactly. very flexible.
And then there are these transformation methods mentioned. Cliprect, scale, translate, rotate, skew. What are they for?
They modify the canvas's coordinate system before you draw. So cliprect defines a rectangle, and anything drawn after that call will only be visible inside that rectangle, like masking tape.
Okay, clipping region.
Translate shifts the origin, the 0, 0 point of the canvas. So if you translate by 10, 20, and then draw at 0, it actually appears at 10, 20 on the underlying dip map. It moves your drawing position.
Moves things around.
Scale.
Resizes subsequent drawing operations. Scale 2, 2. Makes everything drawn after it twice as big.
Zooming in or out.
Yeah.
Rotate. Rotates the canvas around a point, so things you draw after that will appear rotated.
Spinning things. And
slants or shears the drawing along an axis, kind of distorts the shape.
Wow. So you can move, resize, rotate, clip, and slant the drawing surface itself before drawing shapes onto it.
Exactly. These transformations are fundamental for animations and complex layouts. You can even save the current state of the canvas, transformations and all, do some drawing, and then restore the previous state.
Very powerful.
Yeah.
Okay, we talked about drawing simple shapes like rect and circle. But what if you need a really complex custom outline, like the shape of a country or a gear?
That's where the path class shines. A path object represents a geometric contour. You can build it up piece by piece.
How do you build it?
You can use methods like move toe to position the starting point, line to draw straight lines, quad toe or cubic toe for Bezier curves. You basically define the outline segment by segment.
Like vector drawing.
Exactly. It is vector graphics. The notes also mention convenience methods like add rect, add circle, add arc to add those standard shapes to your path easily.
So you can combine lines, curves, and standard shapes into one complex path.
Precisely. And once you've defined your path object, you draw it onto the canvas using the canvas.drawPath, my paint method.
Using the paint object for styling the path, of course.
Of course. Color, stroke width, fill style, shaders, it all applies to paths too.
And I saw something really cool. Draw text in path. You can make text follow the contour of a path.
Yeah, that's a neat trick. You define a path, maybe a curve, and then tell the canvas to draw text along that path. Great for visual effects.
Very cool. Now, there was also shape drawable. How does that relate to path and canvas drawing? It sounded like a shortcut.
It is, in a way. Shape drawable is a type of drawable, a more general Android graphics concept that specifically draws a geometric shape. It sort of bundles a shape definition and its paint styling together.
So instead of manually calling canvas.drawk in onDraw, you could maybe use a shape drawable that represents a rectangle.
Exactly. It's often used for simpler things, maybe backgrounds for UI elements. The notes list predefined shapes you can use with it. Rect shape, rounded corners, oval shape, arc shape.
And even path shape, so you can use a custom path with it too.
Right. It's just a different way to organize and draw shapes, often more convenient for common UI patterns compared to writing custom on-draw logic for every simple rectangle.
Okay, so shape drawable is like a pre-packaged shape drawing tool.
Good way to put it.
To make this more concrete, the notes give examples. A pie chart and a column chart. How would those be built using these tools?
For the pie chart, it's all about the canvas.draw method. You'd have a bounding rectangle, usually a square for a circular pie, then for each slice of the pie.
Representing some data value.
Right. You calculate the starting angle and the sweep angle, how many degrees that slice covers. Then you call draw arc with those angles, making sure the use center parameters too, so it draws wedge shapes.
And you'd use a different paint object or change the color on the same paint object for each slice.
Exactly. You'd cycle through colors, perhaps using color.rgb to generate distinct ones, drawing arc after arc within the same bounding box until the full circle is drawn.
Makes sense. What about the column chart?
That's mostly about canvas.drawRect for each data point you want to represent as a column.
You calculate its height based on the value.
Right. And you also need to figure out its width and its horizontal position. You need to manage the spacing between the columns too, so they don't all clump together.
So lots of calculations for coordinates and dimensions, then calls to drawRect for each bar, likely using the same paint or maybe different ones if you want colored bars.
That's the core idea. It shows how you combine these basic drawing primitives, drawArc, with calculations and styling paint to create meaningful data visualizations.
This is actually starting to form a clear picture. It's like having a set of fundamental drawing tools and combining them.
It really is. And for folks who want to go deeper, the notes link to the official Android developer docs for Canvas and Shape Drawable, always the best place for the nitty-gritty details.
Yeah. Developer.android.com is usually the source of truth. There's also a link to a tutorial on making a pie chart using XML, which might touch on shape drawable, perhaps.
Could be. Those resources are definitely the next step for practical application.
So wrapping this up then, if we boil down this deep dive, the main takeaway is that 2D graphics on Android isn't some black box. It's built on these core, understandable pieces. Bitmap for the image data.
Canvas for the drawing surface and commands.
Paint for the styling, the colors, the strokes, the shaders.
And then the specific drawing methods like draw rect, draw circle, draw path, plus transformations to manipulate the canvas.
Getting a handle on these gives you a solid base for understanding how so much of what we see in apps actually gets drawn.
Absolutely. It demystifies things quite a bit and opens the door to understanding more advanced topics like custom UI components, drawing optimizations, and even simple animations later on.
It definitely makes you look at apps differently. You start thinking, okay, that button background is probably a shape drawable with a gradient shader, or that chart must be using DrawArc in a loop.
Right. It connects the theory to what you see every day.
So, maybe a final thought for our listeners. As you use your apps today, look at the different visual elements. How might they be constructed using these basic canvas and paint operations we talked about? What other questions pop into your head about how mobile graphics work now that you've got this foundation?
Good food for thought.
Definitely. Well, that's all the time we have for this deep dive. Thanks for tuning in.